Start stream. Hi everybody, I'm Tony E at Show IP Interface Brief, and today I've been doing some additional review of the OSPF database, just with a focus on navigating the database and taking a step further from yesterday and starting to inject some Type 5 LSAs. And so I kind of wanted to walk through a little bit to kind of give everyone, since I saw some questions on Discord about how do I manage the virtual environment? Where do I build labs? Where do I get ideas for labs? And stuff like that. So I kind of wanted to kind of show a little bit from scratch what I do. I'm not going to sit here and configure the lab from scratch because this is a very basic lab with simple IP addresses, simple OSPF. Today was just a lesson in navigating the database. So no complicated configurations to figure out or anything. If anyone wants to take this lab and build it, there's a link in the description below. That is a link to my public Dropbox where I have the 6-shooter topology. I call it the 6-shooter because there's 6 routers on it. The 6-shooter topology that you can import directly into EVE-NG, and as long as you have the right images, you should be able to launch it. It is a blank topology, so you'll have to build it from scratch, and so that will help build your skills. This is a simple topology, nothing to it. So let me pull it up on the screen and show you guys what I'm working with here. Okay, so here's my topology. This is the 6-shooter. It has 6 routers, 1, 2, 3, 4, 5, and 6 around the edge, and 3 switches in the middle. I love this topology. Anytime you guys hear me talk about a lab that I've done or a topology that I've built or anything like that, I'm using this topology. I also have some variants of this topology that I might introduce a little later on in my 100 Days of Labbing journey that I've kind of already built and set aside. But generally speaking, I use this topology over and over and over and over. And that's because it lends itself to so many different configurations. And what I mean here is this is the physical topology. For any seasoned veterans out there, CCIEs and everything, you'll understand exactly what I mean. But for some of those guys and girls starting out at the CCNA level, at least when I was at the CCNA level, I had a hard time sort of extrapolating a logical, topology and a physical topology, and I had a hard time understanding that they could be represented radically differently. And what I mean here is, going back to the topology, this physical layout is not actually the logical topology that I built. The logical topology that I built is this. Okay? So what I have is router 1, router 2, router 3, router 4, router 5, router 6. Each one is connected via essentially a point-to-point link. They are broadcast, so they're not OSPF network type point-to-point. They are actually broadcast links because they're Ethernet, but they only connect each other. They don't connect more than 2 routers at any one link. And that's all accomplished via subinterfaces. So just kind of walking through what I did here, I colored the links so we can easily see that they're separate areas instead of drawing dotted lines or large bubbles around them. So routers 3, 1, routers 3, 1, 2, and 4 are all in area 0, and then 3, 4, 5, and 6 are in area 3, 4, 5, and 6. The only additional thing I did is here on router 6, and then up here on router 1, I introduced a single loopback, which I redistributed into OSPF process. So I did that because I wanted to see what the redistributed loopback looks like in this area 0, and then again here in this bottom area, normal area 3, 4, 5, 6. And so even though for people who are very familiar with OSPF and reading the OSPF database is nothing is nothing to them, then this is going to be probably quite boring. But I found that even in my experience so far, that I even learned something tonight, something about the OSPF database, just sort of how to read it and how to understand it. And it was, I mean, that's why we do this. We do this to build that strong foundation. And I want to make sure that I have that. So I want to make sure when I'm presented a topology in a lab environment or in a work environment, in my professional environment, someone gives me an OSPF topology and they just give me access to the database. I want to be able to, using the database only, essentially draw out the network. So I don't know if I'll be able to do that, but I kind of wanted to walk through that exercise live here on the whiteboard. I was going to blank out this whiteboard and start again using the OSPF database, actually trying to map out the entire topology. I don't know if I'm proficient enough to do that yet, but I think I want to give it a try. But before I do that, I kind of want to dive into routers 1 and router 6, since they're sort of diametrically opposed in the topology. They're at opposite ends, separate areas, and kind of see what the OSPF database looks like from their points of view. So I'll go ahead and bring up routers 1 and router 6. You can see here I've already had this going for quite a while. I've been messing around with this database for a while. So the first thing I want to do is show IP OSPF database and just take a peek at the entire thing. This is a relatively small topology, so show IP OSPF database is no big deal to run here. Also, router 1 is in a single area. All of its links are in a single area, so I don't have this like long running database, and that's okay here. So just kind of reviewing this, I think I can drag this down a little bit. The top here in area 0, the router link states, these are our LSA type 1s. All right, and every router, OSPF router, is going to send an LSA type 1 into the area. Okay, and that type 1 is going to include all of the links participating in that area on that router. And we can dive into each one of those. So this tells me that in area 0, I have these 4 routers. And again, I use the router IDs prefixed with 000 because it makes it just really easy to read and understand. So I'm not trying to get confused which is an IP address and which is the router ID. This just really helps me because I'm in like the learning mode to visually see the difference. So this tells me that there are 4 routers in area 0 because each router must send a type 1 LSA in its area. This is telling me that I think router 2 and router 1 are the DRs for these network segments. Okay, that's how I'm reading that. So these LSA type 2s, which is this section here, is called the network LSAs. In this column is going to be our DRs, if there was one. I'm trying to think, what would that? Oh, I was going to say if it was a point-to-point link, there isn't a DR election, so you don't have type 2s. So this part of the database would be blank. But because we are using Ethernet segments, they do elect, that's a broadcast segment by network type broadcast by default, and they do elect a DR, so that's what we're seeing here. So that means that router 2 is the DR for 2 segments. Okay, so that tells me that router 2 must actually have 2 links connected to it, and we can verify that when we look up here. LSA type 3s are the summary LSAs, and that's this section here. And what I wanted to point out was you can see there's some duplicate link IDs here. So 10.1.34.0, 10.1.34.0, 10.1.35.0, 10.1.35.0, and 46 and 46 and 56 and 56. And what you'll see is for each one of them, if you follow it across to the advertising router, each one is being advertised from router 3 and router 4, and again from router 3, and again from router 4, and on down the line. So if I bring back up the topology that I drew, that kind of makes perfect sense, right? What we're seeing here is these links being advertised into area 0 by router 4 and router 3. Okay, and so that's why we kind of see duplicates of those link IDs. And so that makes perfect sense. That makes perfect sense. That was a little interesting to see. And below that in the database, again, we're still on router 1. You have to ignore these top two. It was from a loopback, a little experiment that I did about 30 minutes ago. I think 30 minutes ago, and it's still in my database. I haven't restarted routers or cleared anything yet, so that's still there. This is not active right now, so please ignore it. Here are our 2 loopbacks that we injected. On router 6, I always say injected when we're doing sort of redistribution, I guess. Router 6's loopback and router 1's loopback, and the advertising router is router 6 and router 1, respectively. Now, because we're on router 1, we don't need an ASBR. Oh God, what am I saying? This is a summary to the area border router. Is that right? Autonomous system border router summary. This is going to tell the rest of the areas how to get to the advertising router. So I wanted to take a look here because there was something that I was getting confused with, and that was if I take a look at the routing table, which is the similar data, right? The routing table is populated by data from here in the database. Show IP route. So I noticed something like 10146 is multipath. Okay, and again we're here on router 1, so we're at the top leftmost portion of the topology, and our next hop is router 2 and router 3, and this network is 4.6 and equal cost. So let's bring up the whiteboard. Here's our 4.6 link. From router 1, our next hop is router 2 and router 3. So to get to this link, it is equal cost to get to router 4 to reach that segment. Okay, so we're actually going to load balance or load share to reach that network, which was pretty cool. So then I took a network like, okay, well, if we're load sharing to get to 4.6, why aren't we load sharing to get to 5.6? And we have a cost of 3 there. So let's see, we'll bring up our topology. It's a cost of 3, so this is going to have a cost of 1. And because I know this topology, they're gigabit Ethernet segments, it's a cost of 1 and a cost of 1. So 1, 2, 3 is the total. But if we go another way, it's going to be 1, 2, 3, 4. So 1, 2, 3, and 4. It's going to give you a cost of 4. And if you try to traverse this link in the middle in either direction, it's going to add a cost of 1. Okay, so that's why we only end up with 1 there. So I thought about, what about this link? Why don't we see multipath to this link? And again, it stays true that it's a cost of 1 for the link and a cost of 1 to reach the router. And here we're going to have 1, 1, and 1. So this path is going to be 3, and this path is going to be 2, a cost of 2. So to reach this one, which is the 34 network, we should have a cost of 2. Let's verify. Here's the 34 network, and we have a cost of 2. But if we remember back when we saw the summary LSAs, we had 2 summary LSAs. Show IP OSPF database. We have 2 summary LSAs. So I'm going to call it the prefix of, or the link state ID rather, for the network 34 in the third octet is being advertised into area 0 via router 3 and router 4. Because they can both reach it. But we're only going to choose the one path, which is the shortest path. Shortest path first. Okay, so one of the things I wanted to do here was take a look at why we only have one path to 56, which is something we just took a look on the whiteboard. So I kind of just want to show that in the database, and then I want to start walking the database from router 1 and just sort of mapping it out. Show IP OSPF database. These are summary, and I want to grab the link ID, paste. 56. Is that right? Yes. That is right. Okay, so this was something that I was looking at earlier, and I was looking at this database for a long time, for a while. And one of the things I looked at was, okay, so we only have one route to 10.1.56.0. However, in the database, we have 2 entries. And if we look at the metrics, it's a metric of 2 to reach them. And I kept wondering, well, if it's the same metric, you know, why aren't we load balancing? Why aren't we multipathing this? And I wanted to point out what this is this is a metric of 2, which is the cost. I'm trying to think, how can I phrase this? In order for this router to reach this network, it has a cost of 2. And in order for this router to reach this prefix, it has a cost of 2. Again, let's go back to the whiteboard to see that visually. So here we were looking at 56. And we were looking at it from the advertising router of 3 or 4. So here's 56. In order for router 3 to get to 56, it has a cost of 2 because 1 and 1. And in order for router 4 to get to 56, it has 1 and 1, which is a cost of 2. So it's the same either way. So why does router 1 choose only one path? And that's because the shortest path is going to be to router 3. Okay, which is 1. So we should have a cost of 3 to reach 56. Any other path, if we were going through router 2 and router 4, is going to add additional cost. And so it's only going to use the shortest path and the best cost. And here we have our cost of 3 and our single entry here. Okay. And I kind of pointed that out. I wanted to point that out because looking through the database, there was a number of times when I was looking at the metric value and I was misinterpreting the metric value. Just like what we just looked at, the metric value was 2, and I was thinking that because I was on router 1, it was a cost of 2 for me to reach these routers. And to all of you seasoned OSPF guys out there, guys and gals out there, this is probably just a confusion, a rookie mistake. But that's why I wanted to go through this. I wanted to go through this to make sure that I'm not confusing myself and that I have the experience to go through this. I want to become very comfortable with the OSPF database. And I'm just not there yet, but over the past 2 days, I've been taking steps in the right direction. And I hope this leads me down the right path. So I'm going to go through the OSPF database on router 1, and I'm going to kind of start with LSA type 1 of router 1 of itself. And then I want to go over to the whiteboard and sort of draw it out step by step. So let me put myself over here. Okay, show IP OSPF database. So first thing I'm going to do is I'm going to take a look at the router LSA for myself. Show IP OSPF database router and paste that one in. It's my router ID. And what this is showing me that router 1, which is my router ID, has 2 links. Okay, and here's my IP address and the IP address of the DR on the segment. So we can draw this out. Let's jump over to the whiteboard. I'm going to clear this out completely. And yes, I know what the topology looks like, but remember, I'm going to be using only the OSPF database to draw this. So right now we have a single router, which this is probably too big. A single router, router 1, and we know that it has 2 links. We don't know where they go, but we know our IP address, and we know that there's a DR on the segment. So that gives us a little bit of information. Let's take a look at what our IP address was. One of our IP addresses is 10.1.12.1 and 10.1.13.1. So .1, and this one is going to be 10.1.13.1. Okay, we see that we have a DR, which is the .2. Now, I don't just want to draw another router and mark that one as .2, because right now all we know is that these are our links. There could be 200 other routers on that segment. We don't know how many are on that segment yet. We don't know until we ask the DR how many routers are on the segment. And so we are ourselves, look how these IP addresses match. Router 1 ourself is the DR for this segment. So let's do that segment next. Show IP OSPF database. The DR is the only one that sends out LSA type 2s, which are network LSAs. So let's throw that in there. And what this is telling us is that this was the IP address of the designated router, which is ourself. Here's our router ID. It was a /24 link. So let's add that to our topology. Maybe I should just start over with this guy. 10.1.13.0/24. And that there are only 2 routers on this segment, which is router 1 and router 3. Now, we don't know anything about router 3 yet. We just know that there is a router 3 out there. But we do know that there are only 2 routers running OSPF on this segment. So I'm going to kind of pencil in a router 3, draw him there. But we don't know anything about router 3 at the moment. All right, so now I'm going to go the other way and start investigating our other link. Right, the DR for the other link is up here, 10.1.12.2, show IP OSPF database network. Paste that in. And again, here we can see the IP address for the DR, the router ID, which I should have been indicating the router IDs the whole time. This is a /24, and that there are 2 OSPF speakers on this segment, which is router 1 and router 2. So we should have been indicating that we are 0, 0, 0, 1. There's a router out here, which we know is 2, and this is 0, 0, 0, 2. I should probably put the router IDs inside the router themselves. And that's all we know at this point. We don't know the IP address of router 2. We know that router 2's IP address, the DR, is the .2, so we assume that that's on this segment. But in order to really verify that, we need to check router 2's type 1 LSAs. So I'm going to grab router 2's router ID, show IP OSPF database router. Okay, and this is very similar to what router 1's router LSA looked like. We have ourself as the router ID and the link state ID, and then we have 2 links. And we have our IP address is 10.1.12.2, and that is also the designated router, so that's router 2 is the designated router. And then we get to see that we have another interface that is 10.1.24.2, and it is the designated router. So now we can connect this. Now we know we have an interface here. We don't know what's on the other end, but we know it's 10.1.24.2, and that this guy is the DR for this segment, DR for this segment, and that router 1 was the DR for its segment. I should have pointed out, and I didn't point this out here on router 1. Let me step back to router 1's router LSA. I did not do this initially, so router 1 is 0001. It has the 2 links, and here's the cost, which I can't seem to highlight. Here's the cost for each link. So we should be indicating the cost somewhere on our map. Can I call it a map on our topology? Maybe we'll do cost in green. So the cost of this link from router 1's perspective is 1. Maybe I'll put that in a box, and 1. And let's do that again from router 2. And router 2 has a cost of 1 and a cost of 1, so we can indicate that as well. You're probably thinking, yeah, Tony, well, router 1's cost was 1, so router 2's cost would be 1 also. Yeah, if we're using the sort of the default configuration in this small lab environment, but they can actually have separate costs. You could manually configure separate costs sort of asymmetrically the right way. A cost of 10 this way and a cost of 100 going that way. It might screw up your routing a little bit, or it might be exactly what you intended, but you could have separate costs from different points of view. Okay, so we want to grab the designated router here. Because now we're done with our link between routers 1 and 2. And let's do show IP OSPF database network, which is a type 2, because only the DR sends LSA type 2s, which are the network LSAs. Give the DR address. And so now we see that between router 2, that network between that extends off of router 2's interface that we don't know where it goes, has 2 routers on it, which is router 2 and router 4 that speak OSPF. So we need to indicate that, and that it's a 24-bit mask. Okay, so we know that we have a router here, and I should have done 0004, and that it was a 24-bit mask. Okay, so now what are we going to do? We're going to check the router LSA for this router. Show IP OSPF database router LSA, hit it, and we can see here in area 0, excuse me, we're going to have, we only have 1 link in area 0. This is our router ID. Here's our IP address for our interface, and router 2 is the DR on that link. So we can go ahead and fill in our IP address. The link, the cost from router 4's perspective for that shared link is 1. So lots of good information here this time. So this is 4. It's a /24. We want to indicate the cost from router 4's perspective. I think that's it, right? That's all we have. Okay. So we only have this view of the network. Let's dig into the database just a little bit more. Again, we're still on router 1. We haven't moved from router 1. I haven't left router 1 yet. Show IP OSPF database. And I kind of want to point your attention to the summary LSAs, which are the type 3s. And what you're seeing here, you're seeing the network summaries, which I'm just going to call them prefixes. These are the prefixes that are being brought into area 0, and they're being brought in through these routers. Right? So again, this is what I showed earlier. 34 is being brought in by router 3, and 34 is being brought in by router 4, which makes perfect sense knowing what we know about our logical topology, the whiteboard that I showed earlier, which is 34, 35, 46, and 56 are each being brought in both into area 0 by router 3 and router 4. So we can, I'm trying to think of a good way to sort of indicate that, a good sort of way to indicate that here on the drawing. I'm not really sure what's the best way other than maybe making a list of networks, which would be 34.0, 35.0, 46.0, and 56.0, and just indicating that they are beyond router 3 and router 4, but we don't actually know anything about router 3 and router 4's other links. Let's take a look at the database for a couple of these entries. So show IP OSPF database, and these are summaries. So we'll paste in the link ID there. And because there were 2 entries for the 34 network, one of them came from router 3, one of them came from router 4. They're both indicated here. And again, this is something that I pointed out earlier. Initially, when I was going through this for the past few hours, I was looking at router 1, and I was looking at this network, and I was looking at the metric, and it just didn't make sense to me how the metric was derived until this is how I try to remember it. This metric value is the cost to reach this network from this router. Okay. And the 34 network is actually directly connected to routers 3 and 4. So they give their directly connected networks the cost of the default cost of that link. A gigabit link is going to be 1. We also see that it's a /24. I know that all the links in this topology are /24, so I'm not going to go through and try to find them all. Okay, so that kind of brings us to the end, I think, of what we can do from router 1's perspective. So what we should do now, I believe, is actually move over to router 3 or router 4, or both. And actually sort of investigate from there. Instead, what I'm going to do is actually jump to the bottom corner of our topology, which was router 6, to see what the top half of the topology looks like from router 6's point of view. And from router 6, it should also give me a good view of the area 3456 that it resides. So show IP OSPF database. And again, this is for area 3456, and we're seeing all of our routers that are participating in that area. Every router within the area has to send out LSA type 1s, which are router LSAs, which are going to tell the rest of the area about the links from that router participating in OSPF in that area. Our LSA type 2s, our network LSAs, are going to be sent out by the DRs, okay? And they're going to describe the link, the network segment, and all of the routers that it has seen on that segment. So just by looking at this, I can already know that router 3, router 5, and router 6 are my DRs, because they're the only ones who are going to send the LSA type 2s. All right, and they're the DRs for each of these segments. So again, I'm going to start on router 6 with router 6's own links. Show IP OSPF database router, paste, enter. And here we see router 6 has 2 links. This is an interface IP address, this is an interface IP address, and this is the designated router for that. And you notice that they match. And they match, which goes right in line with what we see here, right? These 2 entries. So if we start at the bottom of our topology and try to pencil that in, we're going to be down here. Do I have the right color? Down here, which is 0, 0, 0, 6, router 6. And we see that we have 2 links. We don't know what's on the other end, but we know that we are 10.1.46.6 here and 6 here, and this is 10.1.56, and we're the .6. Okay. We should also be able to derive the cost from router 6's perspective for each link. And the cost is the metric value, which is 1 on each side. Okay, now let's ask the DR for this segment, which happens to be ourself. If I'm router 6, it happens to be myself, about what are the other routers on this network segment. Show IP OSPF database network, paste, enter, and that's going to tell me our subnet mask and the other routers that are on the link as referenced by their router IDs. So that tells me there's only 2 routers on here, router 6 and router 4. So let's go ahead and pencil this in. I think we can actually start to connect dots here. Okay, so we know that this link connects, oh, excuse me, that was green. I didn't mean to do green. That means that this link connects to router 4, but we don't yet know router 4's IP address on that segment. We can make an assumption because I built the lab, but we haven't actually seen it in the database, so I'm going to leave it blank. All right, we know there's no other OSPF speakers on that link. This could be connected to a switch. There could be other routers on it, but they're not participating in OSPF, so they're not in our OSPF database. So to OSPF's point of view, they don't exist. All right, let's check the other edge there. Show IP OSPF database network, the DR. Okay, this is going to tell us that we have one other router on that segment, and that segment is a /24. Let's bring up the whiteboard. Okay, we know that the other router here is 0.0.0.5 because it showed it in the OSPF database, and that this is a /24, and this is a /24. All right, so now let's go ahead and while we're here, take a look at router 5. Show IP OSPF database router 5. And again, this is just a wash, rinse, repeat. Here's our router 5. We have 2 links. Here's our interface IP addresses, and here's the DRs on those links. So for the 5.6 segment, where 6 was the DR, our IP address is .5, and our other IP address, our northbound IP address, is going to be .5 as well on the 35. And don't forget the cost, which is the metric value of 1. .5. We also know we have an uplink here, which is .5, but we don't yet know the or do we have it here? 10.1.35.5. We can pencil that in. 10.1.35 blank. Okay. We don't actually know what router 3's IP address is, and from router 5's perspective, these links all share a cost of 1. All right, so last we have to do routers 3 and router 4. And again, we're doing this all from router 6's point of view right now. So let's grab, we got to ask the DR. Who is on this link, right? For between router 5 and router 3. Show IP OSPF database network. And that's going to show us that our mask is a 24-bit mask for that segment. And we have 2 routers in the link. So now this gives us which router we need to use to pull the router LSA. Show IP OSPF database router paste. Okay, and this is going to give us 2 interfaces. Here's our IP address for the segment that we were chasing from router 5. Let's put that in there now, which is .3. The cost is 1. Okay, and then we saw that we have another link, but we don't actually know where that goes. Let's see what information it gives us. Our IP address is 34.3, and we are the DR. So 10.1.34 dot something slash something. So we're the .3, and we're the DR. So we need to ask the DR, show IP OSPF database network, ask the DR, and the DR says you got a 24-bit mask on the segment, and there are 2 OSPF speakers, router 4 and router 3. Perfect. Let's grab this. We'll put it in our clipboard. We'll pencil this in. We know that router 3 now connects to router 4, and that this is a /24. And I forgot to indicate that router 3 is the DR for that segment. I think lastly, let's hop over to router 4, show IP OSPF database router. And here's what we were just looking at. 10.1.34.4. We can pencil that in, and we saw that 3 was the DR, and it's a cost of 1. Okay, if we indicate our costs, I think we have it all the way across the board. Now we just need to solve this bottom portion here for router 4, which is going to be here, 10.1.46.4, because 6 was our DR, and it's a cost of 1. So 10.1.46.4, and you are a cost of 1. Okay, that's pretty cool. Now remember what I drew over here, what I drew in red. This was from area 0's perspective. Now let's draw over here in this box from area 3, 4, 5, 6 perspective of what are the summary routes. Router 6, show IP OSPF database. Our summary routes are 12, 13, and 24. Which is 10.1.12, 13, and 24. All right, that's what area 0 looks like to area 3456, which we're looking at from router 6. So from router 6, router 5, router 3, and router 4, it sees anything in area 0 as looking as summary routes. And here's your prefixes. And again, we did that earlier, just about 15 minutes ago. From area 0, everything beyond router, everything southbound below 3 and 4 looked like this. So that was pretty interesting. One of the last things I wanted to look at was these loopbacks that I redistributed into OSPF. I did it on router 6 only and router 1 only. And that's going to inject LSA type 5s throughout the local area and generate LSA type 4s into the neighboring area. So show IP OSPF database down here at the bottom. Here is my LSA type 5 for my locally injected loopback, which is shared amongst my area. And then here is the loopback coming from router 1, which is in another area, which is coming up from area 0. It's injected as an external. And we also get type 4s in our local area, 3, 4, 5, 6, to tell us how to get to the advertising router. So here's our prefix. Here's the router that advertised it or that redistributed it in. And then from our area, area 3, 4, 5, 6, how can we reach this router? Well, we have to go through one of these. Let's take a look at the routing table and see what router 6 thinks. Show IP route, OSPF. It looks like it's doing some multipath. I'm thinking that should be the case because it is an equal cost to go 2 ways. And if you try to cut across the middle, it will add cost to it. Oh, but sorry, I'm kind of like confusing myself here. The cost is right here in front of me here in the routing table, and it's a cost of 20. And it's a cost of 20 because by default, OSPF will inject redistributed prefixes as E2s, which carry a constant metric of 20. Okay, if they were E1s, every hop that they make through, maybe it's not a hop count, every link that they cross, the cost is cumulative. So that's why they're doing the multipath. I should change that to E1 and see what that does. On router 1, I'm going to redistribute connected, and I'm going to call it metric type. Should be they are 2s right now. Let's change it to 1. Okay. Now let's see what that does over here at router 6. Okay, so it gives us our redistributed cost of 20, and I think +3 for each link in the path. Let's bring up our whiteboard to verify. We're down here on router 6. So to reach the loopback, which sits up here on router 1, it's going to be a cost of 1, 2, 3. Or it's going to be a cost of 1, 2, 3. I'm trying to think, or it could be 1, 2, 3, but it's only choosing 2 paths. Well, I'm going to have to investigate that some more. Maybe it's too late for me, or maybe I'm just not seeing it. But there must be It must be the interaction between a normal area and the backbone area of why it's only doing the 2. And I'm not sure what that is just yet. So, but my exercise tonight was trying to teach myself how to walk the OSPF database, and that's kind of what I just did when what I just did with you guys was walk through the OSPF database. I'm not very proficient at it yet. I'm getting there, and I'm trying to start to understand all of the different fields and decipher everything that there is in the OSPF database. So I'm just diving in head first, and this is what I've come up with after 2 days. I haven't seen a really good video on walking the OSPF database. Maybe there is one, maybe there isn't. I hope that maybe one day maybe I can present one if I can, make sure I understand all of the details on the interactions of the LSAs and the areas and link types and stuff. So we're getting there. We're getting closer. This is exactly what I wanted. Was a good deep dive. This wasn't a very strong labbing day, so I wasn't just like sitting here like configuring and hammering away at the keyboard like I do some nights. Instead, I built the topology. It was relatively quick, and I spent most of the time just examining show output and then going back to my my whiteboard topology and looking at the show output again and trying to just sort of correlate the information to make sure I understood it. And that was a pretty good learning experience, but I want to be as comfortable. I'm kind of just like, always beating a dead horse by just saying the same thing over and over, but I just want to be absolutely comfortable with it so that I can see an OSPF database and already in my mind start building the topology, start already sort of logically laying it out. And the only way to get there is through practice, right? And so this is, my large leap forward in getting some good practice in on the OSPF database. I had mentioned, I think yesterday, since I am working OSPF, Nick Russo's OSPF topology, which is here. I will be diving into that. I'm not ready for it yet, I don't think. Maybe I just have a little like fear built in because there was just so many moments where it was way over my head at Cisco Live that I don't want it to be way over my head, so I'm kind of putting it off. But I also don't want to work on this topology and have it be a giant waste of time because I'm not ready for it. So I want to hit it when I'm ready, and I want to be able to solve the problems contained within and be able to sort of map that topology out via the OSPF database. So that's what I got. It's been a lot of fun doing this. I hope to get better at it, more efficient at it. If anyone has any good resources, you can always share them to me on Twitter. You can see my handle below, or you can reach us in on the Discord server. That's where we do our daily chat, and we get to ask questions and get some good feedback. So that's all I have for everybody. Another OSPF day. I think tomorrow I will probably do something a little different because I don't want to get bored with this or it stops becoming interesting. So I think I might do something a little bit different with OSPF and then maybe come back to some more database stuff as we progress. So thank you all for coming with me on this journey through the OSPF database, and here's till next time. See ya.